Oh dear. It has been, I'm aware, for the second time in 2 days, I have been teaching you and not been live. So I do apologise to all of you wonderful people who've stuck around. I am an idiot who's still learning to live stream and evidently not learning it very well. I was so proud of myself to remembering to unmute that I managed to forget to start the go live. So perhaps we need to have words with myself afterwards. I will write some lines. I do apologise to everyone. So let's see where we are up to. Let's start again. I don't know what you could hear, probably nothing. So let's start as if it's me. Hello. We are learning today compound measures. Compound measures, I'm going to teach you what they are, how we use them, and why they exist. I feel very, very stupid. We are going to be looking at all those different things, and there's lots of keywords. Speed, density, mass, pressure, force, area, and volume. If you want to, you can pause the video and go back and find out what they all mean. Or you can watch the video, and hopefully over the course of the lesson, I will be explaining them all to you. Thank you so much for all of those people who joined me and putting up with my terrible ability to press play. Do remember, please, I'm looking for people to send me the work. I love seeing the work. I am trying to survive the whole of this summer stuck at home. So are you. The thing that's keeping me going is being able to teach you wonderful, wonderful people. And I love seeing all the work you've done. So please either email me or put it on the Facebook group so we can, on Monday, we can have a look at all the stuff people have done this week. I'm also setting a Taskmaster challenge every week. I love seeing people do it. I saw Willow had a wonderful attempt at the water challenge, making a boat. I'll have a few more people having a challenge go at that, and there'll be another one at the end of this video. A little Taskmaster challenge for you to all have a go at. Be awesome to see you having a go. I'll also be putting the timetable out later, so keep your eyes peeled for the timetable. And if you at any point do come and I haven't started the lesson on time, it will mean one of two things. One, it means my wife has rushed to hospital, and check the Facebook group to see if I have had to cancel the videos for the day because my wife had to go to hospital because she is very, very pregnant at the moment. Or it means I've forgotten to press live, in which case you just have to be patient with me and be very, very laughing at me when we get that far. So, hello, I can now relax. And for the second time today, I can teach you about compound measures. When we measure things, we find out how much of them there are. For example, if I'm measuring sugar, there's two things I can do. I can weigh it and find out how much it weighs, or I can find out how much size it takes up. I can put it in a cup and measure the volume of the cup and say what the volume of the sugar is. So there's various ways of measuring it. Liquids can be measured in terms of capacity, litres. We can also measure the lengths of things, how far things go. So compound measures, a compound is where you put two or more things together. For example, in chemistry, we make compounds like sodium chloride, which is what we call salt. Sodium is mixed with chlorine to make sodium chloride. In compound measures, we're going to take measurements and combine them to make new measurements. What do I mean? Well, first thing I'm going to do is take you over to my special place of learning, and at my special place of learning, you will all become familiar with my triangles, which I'm just deleting all the stuff I did first because we need to start again. Believe it or not, I've already taught this once to nobody. So here we go. Are you here? You can't tell me. I'm in a room on my own, which is why I never know that I've never pressed start, because I forget to glance over the videos to say, oh, what's going on? So I will turn subtitles on into English subtitles for future ones. I do apologise if your sound's not working this time round. I am going to try and do the best I can now, and I'll put the subtitles on for the video afterwards. So, all of these triangles look like this, and we're going to do one for each one of the things we're talking about. So I'm going to be copying this and doing another one here and another one there, over the top of that one. And then we need to learn what goes in them. So the first one we're learning is S D, and T. Distance on top, speed and time on the bottom. Speed equals distance over time. Speed is the S, distance is the D, and time is the T. And the things we have to remember is the units, which we will talk about later, is our helpful bit. The units are there to, excuse me, don't know why I'm sneezing. Speed, distance, and time. The units are either meters per second, kilometers per hour, and miles per hour. Notice for per, I'm using the slash. It means divided by. But we're going to use this to help us. How are we going to do it? Let's start with a question. The question says, I go 400 meters in 50 seconds. What was my speed? And these are the steps that if we learn these steps, you will get all questions to do with compound measures correct. You take your finger and you put it over the thing you want to find. In this case, it's speed. And I think today, just so you all know, I've got lovely red nail varnish on, so you can see that's clearly my finger. It's beautiful. I know you can see that now. And I put my finger over there. That shows me that it must be distance divided by time, because they're the two things left. Distance divided by time. So I'm going to do 400 divided by 50 must be 8 meters per second, because we're dealing with meters and seconds. It's very important that we have the units and work well with them. What's going to happen now, I'm going to do one where it works the other way round. Let's delete my finger. Ow, ow, that's painful. And then, what about if the question says, I am going to go at a speed of 19 meters per second, and I'm going to do that for 20 seconds. How far do I go? This time it's distance we want to know. So I put my finger over distance. And in the time we've been talking, I've also, because I'm so good at multitasking, I've painted my nails. So I've now got green nail varnish on. It looks beautiful, doesn't it? I know that's what you're all thinking. If you could talk to me, you'd say it does. This now tells me we need to times those two together, because we've covered up the top one. When you can see the two bottom ones, we times them together. So we're going to do 19 times 20 is 380 meters. Again, I've got meters per second, seconds, so this must give us meters. That's where we know what our units are. So the first thing we need to do is practice that. Hopefully you've all got a pen and paper. You've got 4 questions. And here they are. Am I on the screen? Possibly. I don't know. I'm going to give you 4 questions in a second. You're going to do your best at them. I'm going to say some hellos, check that you can all hear me, check what's going on, and we will then see the answers to those questions. So, I'm going to disappear. There's the questions. Have a go at them. Hello, Nina Hurst and Daniels. Do apologise to all those people who are hanging around. I'm really apologetic. I feel really awkward. Yeah, maybe I was. That's what it was. I spent 10 minutes just holding on the thing. Sadly, it's now 3 times I think I've done this without actually starting. I need to give the Midnight Star a way of contacting me in emergencies. So if he's here and I'm not, he can let me know, sir, you haven't gone live, because it's a very sad thing to do, isn't it? Willow's back from this morning. This morning, Willow decided that all our followers on this channel is they're the Harris Hawks. So that's fantastic. Well, what about the leagues, Nina? What do you mean about leagues? I haven't seen what you mean by leagues. But Nina, yeah, this was on a live chat earlier with the Harris Hawks. Willow was saying that all the people who come onto my videos can call themselves the Harris Hawks. They're all like a team. It's entirely up to you whether you use it or not. Harris Hawk is a type of hawk, I believe. So it's a hawk, and it was to do with the fact that Willow felt that we all work together and flock together like a hawk might. I don't know whether it's because we eat birds that have been run over on the floor. Probably not. So that's how see how we're getting on with these. If you're doing this and it's not live, feel free to pause the video if you need more time. It's a video, you're allowed to do that. But here are the answers. 10 meters per second because it's 100 meters divided by 10 seconds. 200 kilometers in 4 hours. 200 divided by 4 kilometers per hour. Notice the units are quite important. 120 miles in 3 hours is 40. But this is the bit that I needed you to spot. You do not do 1,500 divided by 5. It's not meters per minute. It's meters per second. So we needed to turn that 5 minutes into 300 seconds. Then, when you get 300 seconds, it's 1,500 meters divided by 300 gives you the 5 meters per second. Because the units, as I've already told you, are always meters per second, miles per hour, or kilometers per hour. Hopefully, that helps you with speed. Remember, we're always using our fingers to cover up the thing we want to find. And this was the speed that we were looking for in all of these. So, here we go. Again, we have now covered speed. We're moving on to density. Now, I should tell you a little bit about... A friend of mine was telling me he's changed his name ever since this live stream. He was feeling a bit miserable. He's changed his name to Lisa. He said it's given him a whole new Lisa life. Oh dear, just a little few seconds for that to just get over that terrible joke. I'm sure I would have more followers and subscribers and things if I didn't tell such bad jokes, but there you go. Now, density. Density is how closely together things are packed. So, if I've got three people in a really small space, they are very densely populated. It is a very dense population. Well, let's say instead of 3, I've got 100 people. Put 100 people in, say, one room. It's going to be very dense. The density is going to be high because there are lots of people in a small space. If I put those same 100 people in a field, they're going to be able to be far more spaced out. Because of this, density must be a compound measure. It's got the space and the number of things. Now, density in general can be applied to lots of different things. So in geography, you'll talk about population density. In other things, you'll talk about other things' density. But we're going to talk mainly in maths about density involving mass and involving volume. So we're flipping to my other thing, and we're going to get rid of all this stuff about speed for the moment. So we've got a bit more space. And we're now going to look at our next one, which is going to be density is mass over volume. Density is mass over volume. Mass is a bit like weight, but mass is still going to be your mass even if you're in a gravityless environment, whereas weight is only on Earth. Mass would be that would be how much you weigh even in without gravity, but weight involves gravity. So we normally talk about mass, which is in kilograms, grams, etc. And so we've got mass is M, density is D, and V is for volume. Not volume like this, or volume like this, but just volume as in the space occupied. And there are again 2 units that are standard here. Grams per centimetres cubed or kilograms per metre cubed. They are the 2 units you're looking out for. If you've got a mix of units, you need to do some rearranging, a bit like we did with the speed question. If you've got a mix of units, you're going to rearrange, and it works the same way. So let's generate a question. What if I have got a bit of material that weighs 200 grams? And it takes up a volume. It's like a bar of gold. It takes up a volume. The first one we do, we're just going to say what the volume is. It takes up a volume of 40 centimetres cubed. Well, the thing we want to find is what is the density. So if we want to find the density, we're going to take our finger and cover it up. You have to do the little song while you're covering it up. You don't need to draw the thing. You can actually just use your finger to cover it up. And the lovely purple now varnish now. I'm just drawing it so you can see exactly what I'm doing. I'm covering up density, which tells us mass divided by volume. So we're going to need to do 200 divide by 40 equals 5. And the units are given from the grams and the centimetres cubed, so it must be grams per centimetre cubed. Okay, and the density, it will tell you how likely it is to float. If its density is bigger than water, it will sink. If it's lighter than water, it will float, which is why wood floats. It has quite a small density. There's air pockets within the woods and the grains. Okay, one more question. In order to do that, we need to get rid of my finger. Ow, ow, ow! Oh, don't get rid of my triangle. I mean, that's the worst thing to do. So, we're now going to find, what about this question, sir? I have got a substance, and it has got a volume of 5 meters by 2 meters by 4 meters, and it's got a density of 1.7 kilograms per meter cubed. So the first thing we're going to need to do is find out what we're going to do. We want to find the mass. So we're going to need to put our finger over mass. Not the nicest of nail varnish there, is it? And sorry, I am slightly insane. Mass. So that tells us to do density times volume, 1.7. But we don't know the volume, so we have to do a calculation here. We are told it's a cuboid, so we're going to draw it just to remind ourselves. I always like to draw drawings. That's not the best drawing, but it should tell you that's a cuboid. And then we're going to do 5 times 2 times 4 is 10, 40 meters squared. So we're going to times it by 40, and it will tell us that it's got a mass of 40 times that is 40, and 28 is 68 kilograms, because we've got kilograms per meter cubed and meters cubed. So we're times them together because we covered up mass, and it tells us it was 68 kilograms. We have got our second compound measure. Any questions? I'm glad you're all keeping up with me. So, are you all happy with that? Hopefully that means that we now understand speed, which is either meters per second or kilometers per hour or miles per hour, and we understand density, which is how closely packed everything is. The next one is pressure. Pressure is how much force is applied over a given area. For example, I can have this here, this sellotape, put it here, and it's not currently moving. But I'm not putting much force into it. I could put more force, and there'll come a point where I can put enough force that it moves. But the pressure on a thing is the amount of force that's being applied over a given area. To test this out, it's if you put your hand, the whole hand on the table, you can push it a lot harder than if you just put your finger. Even if you push all your energy through that, it's harder, it puts more pressure on the end of your finger because it's harder to put more force over the area would be bigger. Therefore, we're going to flick back to here, and that gives us our final triangle, which is going to be pressure equals force over area, where your pressure, and I sometimes think PFA and DMV, Department of Motor Vehicles, and Professional Football Association. That allows you to remember where they go. It's always F at the top, M at the top, and D at the top on this one. But it's exactly the same as before. Force, and we need the pressure is our compound measure here. Area is kind of a compound measure as well because it's meters squared. Force is measured in newtons, named after Sir Isaac Newton, and pressure is newtons per meter squared. And you can also have newtons per centimetre squared. So, in order to do these questions, they work exactly like all the ones we've done so far. So when I do this, hopefully some of you will be like, yeah, we got this, sir. We understand exactly what's going to be coming up here. I don't want to draw in front of myself, so I'm going to make myself disappear so you can see everything I'm doing. We've got what is the pressure if the force of 6 newtons is applied over an area of 15 centimetres squared. Well, we're going to get our finger, cover up the pressure because that's what we want to find. Draw our nails on it. Remember, you're not drawing these, you're just going to write, you're just going to put your finger on the actual thing, but I can't put my finger on the screen. That tells us to do force divided by area, so we're going to do 6 divided by 15, which I think simplifies down to 2 over 3. No, it doesn't. It divides by 3. It goes divided 2 over 5, Mr. Harris, which is 0.4 newtons per centimetre squared. So we're taking 0.4 because it's 2 divided by 5. The top number divided by the force divided by the area. 6 divided by 15 is the same as 0.4 newtons per centimetre squared. And this is the amount of pressure being put over that space of 15 centimetres squared. When we apply 6 newtons, you can see the more force over a smaller area would actually make the pressure higher. Which is why if I put my hand on a balloon and push down, it just squidges. If I put a pin, which has got a tiny area, and push down, that force goes over a much tinier space. So it'd be the force divided by a tiny number, and when you divide by a tiny number, you get a huge force, which is why the thing actually can burst, because the small pin can apply a bigger force over that tiny area, makes the pressure so much that it goes poof, explodes. Okay, so what we've done here is we've dealt with some compound measures. The next thing to do is very, very quickly talk to you about working backwards. How can we use the units? If you're ever doing a question on compound measures and it gives you the units in the question, for example, it says grams / centimetres cubed, that reminds you what you have to do. It's telling you to do grams divided by centimetres cubed. So if you ever do get stuck, and you won't because you'll have learned the triangles that I've taught you, if you ever do get stuck, just look at the units and think, oh, the units are newtons per metre cubed. So I need newtons and divide them by metres cubed, because per means divide. So we can always find out from the units. If you ever get stuck and you're like, I can't remember what to do, use the units. The units help you to remember what you have to do. But those triangles are supposed to are really going to be helping you to get that finished. So, I'm aware that this lesson was supposed to be about half an hour. It's over half an hour, but mainly because I sat in silence for 8 minutes. My apologies. If you've just come to this video now, you'll be like, why has he spent so much time going on about that? Because you weren't here live, so you didn't experience the live people sat here going, where's Mr. Harris gone? He's not coming on. And we'll forget it ever happened, and we'll edit it out, and we'll pretend they're all the ones going mad, not me. So, there's a compound measures worksheet in the description below. Just click show more, and you'll be able to find it. And my challenge for you today, can you make something that can stay in the air the longest? It cannot be attached to anything, you cannot hold on it, and it cannot be battery operated. I'd love to see what you come up with. There's a challenge for you. I know Willow will probably give it a go. Who else is going to challenge Willow? I'd love to see what you come up with. So, this is what we're doing. And that's the screen I want you to be at. So, hopefully, you're now going to be able to find out exactly what to do when you're coming to compound measures. Certainly some of the year 10s I teach will be able to do better at this one now. This has hopefully been helpful. I've been Mr. Harris. Auf Wiedersehen. Goodbye. So long. Farewell. I'm not going to do a song. But if you've got any questions, you've got any feedback, anything, let me know. Do drop a like on the the video if you've enjoyed it. The more likes, the more people come across it, the more people are going to learn maths, and we can help more people in this horrible boxed up thing. I'm going to be putting a timetable up for the next week's lessons. So there will still be lessons, even though it's Easter. I'm still going to try and do a timetable of things because I know some of you are coming along and learning some maths. I've been Mr. Harris. You've been awesome. See you later.